Okay, today, Algebra 2, Lesson 64, we're going to talk about using logarithms. This is another one of those lessons that is really EOC heavy, really heavy on the evaluate. It's not, what you're covering today is not especially difficult, but there are questions that we haven't gotten right on the evaluate simply because I haven't taught it yet. Okay, so maybe been sneaky from here, a couple of times. But a logarithm is the exponent that is applied to a specific base to obtain a given value. Every exponential equation has a logarithmic form, and every log equation has an exponential form. They're just different forms of the same equation. Okay? So we can take a logarithmic equation and turn it into an exponential equation, and then we'll understand it because we're used to working with exponential equations. So what you're seeing here with these arrows on the left is you're seeing that exponential equation. A number to an exponent equals a number, right? So what that allows me to do is that if I want to put that into logarithmic form, is that that number that I'm starting with now becomes the base. So I add the word log, I drop that number down, and then the exponent and the solution trade places. Okay, so number comes down, exponent and solution trade places. Now, if I want to get a logarithmic question into an exponential form, I do the vice versa of that. I'm going to bring that base number up, and then my number and my solution are going to trade places. Okay, the solution becomes the exponent. All right, so I kind of usually draw it up a little bit like this. If I have let's say log base x to the y equals z, something like that. That is the same thing as x to the z equals y. I don't know if that helps you at all or not. Okay. All right. So if we're looking down here, the logarithmic equation, log base b a equals x is read as the log base b of a, equals x. Notice that x is both the exponent and the logarithm in the equation above. So a lot of this today is really just converting between log form and exponential form. And if you can do that, you're going to get a lot of these questions right. I think a little while back, we had a SMART goal on logarithms, which we all did really, really poorly on, right? Because it hasn't been taught yet. So my hope is that after you get a little bit of practice, we'll come back to that SMART goal, and we should be able to ace it, right? Should not be a problem. All right, so a logarithm with base 10 is called a common log. Let me put it this way. If I had something like this, what is the root to this? What do we call it? What is the number that's in front of the radicand? Square, or 2, right? Even though we don't see it, there's a 2 there, correct? Which means if I'm trying to break something down, I need 2 of something before it could come out, right? If it was the cube root. Now, we don't ever really put that 2 there, right? I mean, if it's square root, it's understood. Now, if it was anything else, we would have to put that other number there. Like, we would have to put a 3 there. But it's understood that if it's not there, that there is a 2, correct? Okay, we get that? Okay, and we do that with a lot of different things. So like if I have a variable, what number is in front of that? 1, right? So we have things in math where there is a number there that is understood to be there when it's not shown, correct? Okay, well logs have that same principle in that if, let's say I had log 4 with no base underneath of it, no little subscript number. The understood number is 10. Okay? So we're used to seeing numbers that are there that we don't always necessarily see. Okay? In this case, in the log form, the unseen understood number is 10. If no base is written for a logarithm, the base is assumed to be 10. So for example, log of 5 is the same as log base 10 of 5. Okay? Do we understand that? Again, we're kind of taking one step at a time together here. All right, so that's it in terms of notes. Let's see if we can get into a couple of questions here before we run out of time. Okay, so we have 2 cubed equals 8. We want to change that to log form. So what's the first thing I want to write if I'm changing something to log form? Log, right? Keep it simple. First thing I'm going to write is log. Okay, where does the 2 go? It drops. It falls down, okay? I'm going to get an equal sign. Okay, where does the 3 go? It goes across. It becomes the solution, which means the 8 is the of part, right? So log base 2 of 8 equals 3. Does this make sense? So we should see that answer. Log base 2 of 8 equals 3. I think that's B. Okay, nothing too difficult there. Okay, let's look at number 2. It says log base 4 of 16 equals 2. I want to change that to exponential form. Okay, so we're going to get rid of the log. What happens to the 4? It goes as an exponent? No? Where does the 4 go? Keep in mind what we just did. All you're going to do from, if I'm taking something from exponential to log form, right, we understood those steps, right, John? Okay? All I do is reverse those steps to get a log form back into exponential form. Okay, so what happens to the 4? Well, the same thing that happened to the 2 except in reverse, right? From question 1. Remember how that 2 dropped down? Okay, so this 4 is down. What's the opposite of dropping something down? Moving it back up, okay? All right, so over here with question number 1, right, the 3 switched sides and became the solution, right? So what is the exponent of question number 2? It's 2. Look, guys. Right? Yeah, we do want a statement that's true. So 2 is going to come up and be the exponent. 16 is going to go back across and become the solution.
I was looking at A, that's why I said A. Number 1.
Oh, you were looking at A?
Yeah.
Okay, and our answer is B, right? Okay, so yeah, compare the question from 1 to the solution, right? And do the reverse. Okay? So the reverse is 2 comes up, 3 becomes the exponent, 8 becomes the solution. It should give me a true statement. So that's one way I can test. If I'm going from a log form to an exponential form, my solution should make sense, right? It should work. If it doesn't work, then we have something in the wrong spot. Okay. Okay, now we get a word problem, which we love. Okay, wildlife biologist in Nova Scotia is testing the pH of stream water. She hopes the pH of the water is greater than 5.5 so that the Atlantic salmon will be able to reproduce in the stream this year. The hydrogen ion concentration of water is 0. several zeros 19 mole per liter. To the nearest tenth, what is the pH of the water? Okay. Note pH equals negative log and in hydrogen. So all you really have to do here is you're just plugging this into a calculator as negative log base 10. You're keeping it in base 10 as 0.12123451234519. You're just going to plug that into a calculator and get your decimal answer. There's not really more to it than that. $5.7. Yep, it's right there. Okay, somebody want to scroll down to the bottom, double check that answer. Is that correct? Okay, good. All right, let's look at, let's see, what is probably, number 4? We got 4 cubed equals 64. We want that in log form. John, I'm going to come back to you because I want to make sure we've got this down, okay? So what's the first thing we do when we switch from exponential to log form? What do I need to write first? Log. Let's start with log. Okay, bring down to 4. Okay, 3 goes to the opposite side. And that's amazing. I don't even see the hand moving, Axel, his mouth, but that's awesome. All right, so where's the 64 go? Right here, right? So log base 4 of 64 equals 3. Same way 4 cubed equals 64. Okay? All right, let's skip down. This one I actually do want John to answer this time. I want to skip down to this question here, number 6. I've got 7 to the 4th equals 2,401. I want to write that in log form. Start off with log. Okay. Then what? The exponent would be the 4. Did you say the 4 will go down? No. 4 doesn't go down. 7 goes down. Okay. What number goes above the 7 but stays on this side of the equal sign? 2,401 equal to 4. Good. Okay. Good. Are we getting this? Okay. Let's see. Joule. Number 7. We want to take the log form and make it exponential. 2. 2 to the x equals 16. Is that what you said? Exactly. Great. Perfect. All right. Do we feel like we've kind of got this, or do we need to do some more examples? Pretty easy. Do you guys want to look in your book real quick and see if there's anything that you are fearful might give you a problem? Sounds like we're pretty comfortable. So I'm going to hit H. H is pretty well identical, I believe, to question number 3 we just did. The acidity of a liquid is measured in pH, given by the function pH equals negative log times hydrogen, where hydrogen plus represents the concentration of hydrogen. It's giving you the same thing. Rainwater is 0.0000200 moles per liter. What was the pH of the rainwater to the nearest tenth? So you're just going to type in negative log, and in parentheses put 0.0000200, close parentheses, hit enter, and that should give you your number. Okay? It will probably be a little bit different. Don't expect the exact same solution from what you got from question number 3 on that page. But I don't think there's anything to worry about there.